Alright, here's another video from my No Frills playlist to help you out the next time you've got a physics exam. This video is to do with Newton's second law. Okay, so I'm going to show you what Newton's second law is. I'll show you how to use Newton's second law in calculations. I'm going to show you what inertial mass is. So, quick question. Is it easy to make a heavy person accelerate on a sledge? The answer is no. Is it easy for a giant oil tanker to change direction? The answer is no. And you'll find out why in this video. So, what is Newton's second law? Let's do a demo to explore the question. It's what I call my Newton's second law science trolley demo. Right, I'm sure you've lived on this planet for more than 12 years by now, so you'll probably already understand Newton's second law without even realising. If I push an empty trolley using a small force, will its acceleration be big or small? Well, its acceleration will be small. What if I push an empty trolley using a big force? Will its acceleration be bigger or smaller than before? Its acceleration will be bigger. So, you already know that if you push an object with more force, it will accelerate faster. Right, what if I load the trolley with more mass and give it a push? Will it be easy to make it accelerate? No, its acceleration will be smaller. And you already know it's harder to push a heavy object. Alright, its acceleration will be smaller. Congratulations, you understand Newton's second law. Now, let's put it together what we've learned in that little demo. So, Newton's second law. For 1 mark in an exam, you tell the examiner that Newton's second law explains the relationship between force, mass, and acceleration. So in other words, if you place a force onto a mass, you'll be able to work out how much it'll accelerate. So how much an object accelerates depends on the resultant force acting on the object for 1 mark and the mass of the object for another mark. Let's have a look. So we've said the bigger the resultant force, the bigger the acceleration. So I've got 2 cars, they've both got the same mass, but one of them's got a big force on, one of them's got a small force. The examiner might ask you which one's going to accelerate more. Well, the object with the biggest force on will have the biggest acceleration. And again, that's because the masses are the same. What if we keep the forces the same this time, but we use the force on a small mass and on a big mass? Well, the bigger the mass of an object, the smaller the acceleration. And this is another example of an statement. The bigger the mass, the smaller the acceleration. So there we are. The bigger the mass, it had a smaller acceleration. And again, I've done an example where the force is the same on the car each time. Right, how do you use Newton's second law in calculations? Well, the equation for Newton's second law, if we represent Newton's second law mathematically, the force equals the mass times by the acceleration. We often just write F equals m times by a. If you do need to rearrange it, let's say you've got to work out what the acceleration is, cover up what you're looking for, and what you're left with is how to work it out. So acceleration equals force divided by mass. And you will sometimes get a mark in an exam for being able to rearrange the equation. What if they ask you what the mass is? So cover up mass, and that leaves force divided by acceleration. If you want to explore that a little bit more, click the link at the top now. It'll take you off to another video on Newton's second law that I've made. Right, what is inertial mass? Do you remember mini plenary 2 from the demo at the start, where we found out that it's harder to push a heavy object? The acceleration will be smaller. Well, the definition of inertial mass is if you've got an object and it's got a huge mass, it will be difficult to make it move. And once it is moving, it'll be difficult to stop or change direction. We say it's got a big inertial mass. Examples of large inertial mass would be an oil tanker and a cement football. Here's the equation for working out inertial mass. Take the force and divide it by the acceleration. So you'll notice it's just a rearrangement of Newton's second law, m equals F over A. And the meaning is the mass of an object can be found from the ratio of force divided by acceleration. So that's once again based on the explanation on the calculation. If you wanted to see an example of inertial mass, there's a link to the cement football prank, and an example of a small inertial mass would be when you hit a shuttlecock. So your force would cause a huge acceleration, and that's because the shuttlecock has got a very small inertial mass. There's loads of videos on the internet that would demonstrate that. Well, in the video there, that's a quick 9 marks worth of content, all to do with Newton's second law and a little bit to do with the inertial mass. So well done, keep finding things out for yourself, keep developing your R&I. Work hard, be nice, and I'll see you in the next video. Bye for now.